Hello, everyone. Welcome to Andy's webinar. And I'm Simon Wang, the Senior Technical Marketing Manager from Andy's, and also the Semiconductor Automotive Functional Safety Professional qualified by SGS-TUV. And today we're gonna have a talk about the innovation in automotive WE architectures, embracing RISC-V to meet the coming vehicle systems. Okay, we know the automotive industry is accelerating into a fast track. Here I summarize four major technical items. The first one is the electric vehicles. And we know Tesla has announced the Model 3 in 2019. And according to the press, the Model Y has been the best-selling cars in Europe in 2023. So we know the electric vehicle is already a reality and ready to replace the traditional car in the futures. And the second one is self-driving vehicles. In 2022, Mercedes Layer 3 autonomous driving certified by German government. So actually, Layer 3 is a different level, different gain of the autonomous driving, since the computer is actually taking over the driver's seat, and the human being, just assist and help the computer to drive the car. And the third one is the software-defined vehicles. As we spend more time in the vehicle, in the cars, we can make the time much more valuable. Like we can have maybe watching video streaming, we can have a conference, have a talk with your friend. We can take a view outside and maybe order some food during your traffic. So our vehicle becomes connected and updatable software platform to add new features. So including the infotainment system and the vehicle control, ADAS, or digital cockpit. So there's a report indicate by 2028 or 2029, there will be half of the new vehicles may have software-defined architectures. The fourth one will be the coordinating driving vehicles. As you see from the technology V2S, vehicle to everything, the information now between the car and its surrounding is constant and two-way. The car is not only a separated car, it's just part of the smart city. We can make a better transportation experience by connecting the car with the city network. So there's a report from the 5G by 2029. Dynamic intersection and cooperative traffic flow may be mass deployed. Okay. So here's some motivation for new WE architecture. For example, we need to reduce the system complexity. In the modern car, the system is too complex and it lacks of the flexibility and extensibility to adding new feature, and it also restricts the development speed. As you can see, if there are many ECUs, so when you add ECU, you add many wires. So actually the wire harness becomes the second and the third heaviest part of a car, and it will be the third highest cost component of a car. Then we face another problem is the tightly coupled software and hardware. In the past, ECU is designed for a dedicated purpose, so the software and hardware are tightly coupled with them, and make it hard to implement a complex function across the multiple ECUs, and it is very hard to have a over-the-air upgrade of the software. And for the more and more functions, features, intelligence into a car, and there are more and more sensors, so the network bandwidth will be grows significantly, and computing power grows as well. Okay, so the evolution from WE architecture will be scalable and centralized architecture for the software development, such as for the software-defined vehicle and over-the-air upgrade. And we also keep simplify wiring and connectivity to reduce cost and make ease of hardware upgrade. The traditional architecture is distributed. As you can see, there's many ECU designed for dedicated purpose. And now we are moving into the domain architecture, such as ADAS domain. There will be a in-vehicle infotainment domain or powertrain domain. There are more powerful chips, powerful CPU to deal with many features in one domain. And eventually we'll go into the zonal architecture. There will be a few supercomputers in charge of many works, many tasks, many functionalities just into compute in a few supercomputers. So okay, so what's the RISC-V advantage in the automotive industry? I separate two parts, to silicon vendors or to OEM and tier ones. To silicon vendors, RISC-V is very high performance efficiency. It is state-of-art design, clean slate design. There's no much legacy, and it also is modular ISA design. It means you can choose and select a very compact base as your CPU architecture. Then you can drive in vacation for your domain specific functionality. You can customize it. You can make many extensible and flexible design innovation on it. And there's no doubt RISC-V can provide outstanding PPA, and the architecture is very scalable from the MCU to data center. And it also provides a flexible business model, and the ISA standard also considers security, such as memory protection, hardware enforced isolation, such as TEE, trust in security environment, and some virtualization or even the crypto instructions. To the OEMs and Tier 1, and RISC-V bring you multi-sourcing and supply chain security. You can have a second choice of the CPU ISA. And RISC-V is open ISA. It means you're popular for the software ecosystem. You'll be rich individual software party or open source resource you can leverage on. And there will be more vertical integration with the value chain, can do differentiated and competitive solution by extending the RISC-V solution. And also RISC-V solution is functional safety and security compliance. Okay, RISC-V is already proven and adapting everywhere from the edge to data center. So automotive electronic will be also a good segment to landing. From the report from Semico Research, the RISC-V will have 146.2% CAGR from 2018 to 2025. Okay, there are also some RISC-V growth momentum led by the industrial leaders, such as you can see, Bosch, Infineon, NSP, Nordic, and Qualcomm, and more company, they are leading semiconductor industry player to join a new force to accelerate RISC-V. And Renesas also adopt RISC-V moving to the automotive market, and other companies like Mobileye, EPR, and NSI also adopted RISC-V for their ADAS or their computing processors. Other like Rambus adopt RISC-V for their root of trust security solution. Nera adopt RISC-V for their AI solution for automotive. EliteTech also adopt RISC-V for their TDDI, the touch and display driver integration solution. And there are other many individual software vendors like IM GreenQs providing RISC-V functional safety compiler Umbrella is doing the virtual platform, the simulation model, virtual open system do the secure monitor for the critical environment, execution environment. And also other tools like Parasoft, LDRA, and SolidSense to provide software tool to verify the functional safety software for RISC-V. Okay. And how about Ennis? Ennis is supporting RISC-V for automobiles, for the automotives. Ennis was founded in 2005. Okay, and we joined RISC-V Foundation and promoted as founding member in 2016. And in 27, and is delivered one of the world's most licensed RISC-V CPU, NS25 and N25. Which more than 200 licensees and more than 500 KK shipments already. And in 2020, any development process certified with ISO 26262 SUD is the first RISC-V CPU IP supplier certified with ISO 26262. I mean the process ISO 26262 process certified. And in 2022, NDIS delivered the first full compliant RISC-V CPU certified with ISO 26262. And there were already more than 10 customer tape out and mass production with N25 SE. And in 2023, and 2024, and we keep deliver course certified with ISO 26262. The D25, which is N25 plus the DSP SIMD packet RISC-V P extension. And in 2024, we will deliver D45 and D23 SE. There are more and more cores which soon follows. Okay, so how do we claim our solution is safe? So we follow the industry standards. The fundamental is the quality. Okay, how is the quality? So we follow the ISO 9001, the quality management system standard. And for the reliability, our customer will follow the AEC-Q 100. There will be failure mechanism-based stress test qualification for the IC. And for safety, we follow ISO 26262, the road vehicle functional safety standards. What does the ISO 26262 functional safety for automotive means? It is the state-of-art, internationally recognized standard and providing the common vocabulary on safety from components to the whole system. And it also bridges the gaps in the automotive electronic supply chain, and as the evidence of the effort, how we prevent hazard, the hazard being performed. So what is ISO 26262 automotive functional safety standard? By the definition, it is to prevent unreasonable risk due to hazard caused by malfunctioning behavior of WE system. It is the concept of safety by design. So from the fundamental, from the requirement spec, the design, the information, integration, how we verify, how we validate, and how we configure it. It also consider all things to prevent the risk. Okay, so there were two faults to avoid. The first one is the systematic fault, and the second one with hardware random fault. Let's talk about in this page. The systematic failure means a failure related to in a determinist way to a certain cause, like a design error or some software bug. So we use the process, a certified process to deliver, to implement, design, validate, verify this solution with process. For the random fault, it means a failure that can occur unpredictably. There are more There will be ISO 262 product certification, like FNEDA report to analyze the risk, analyze the risk due to the hazards. Okay, here's the certification and the certification by ISO 262, the process certification with SUD. As you can see, we comply with the additional 2018 for the part 2, 6, 5, 6, 8, and 9, and we certify with HSS TUV. And here's our product portfolio for the functional safety RISC-V CPU IP. In 2023, we have compact level for the automotive MCU ECU, such as body control applications. We have N25-SE, which is a 5-stage single issue. The IP is available now and certified with a COB already, and there also more than 10 SoC chip vendor tape out mass production. And we have the 25-SE, which is 5-stage single issue, and the IP is available now and we'll certify in Q1. For the mission critical, like powertrain or chassis domain controller, we have the 45-SE, which is 8-stage DUH pipeline processor. And the IP will be available in Q1 and will be certified in Q3. And there will be a low power and security enhanced for the automotive MCU and CU, which is the 25SE, 3-stage single issue. The IP will be available in Q2 and certified in Q4. And we have this one, the high performance processor for the ADAS cockpit or infotainment system, which is 60 series 13-stage out-of-order 4-way CPU. And the IP is available now and will be certified by 2025. Okay. Not only our CPU IP is certified with ISO 262, but also our customers' chip also certified and mass production certified by ISO 262 COB and already mass production, which is Elitech TDDI SoC adopted and is N25-SE. And here's the certificate here, as you can see. So, and this is the first RISC-V full compliant core, provided first RISC-V full compliant core, and this core N25SE here. And here the application real case our customer adopted, like in carbon radar, automotive in carbon radar, the automotive CMOS sensor, automotive TDDI, touch and display driver integration, and automotive MCU and automotive camera SoC. So we know ecosystem is very critical for the RISC-V software and automotive market. We have co-worked and collaborated with global leading supplier in the automotive industry. As you can see, such as security, like Rambus, Secure IC, and some trust in execute environment, like virtual open system, being part of trust kernel. For Safe Autos, we collaborate with Safe Autos, Microsoft Azure Autos, VS and AutoSAR, we have did collaborate with Better AutoSAR, and also other like Siemens and FPT software. For the compiler and debugger, IR and GreenQs already supported RISC-V functional safety compilers and others like Tasking, Ashling, and we are talking, meeting with also high tech. Okay, and they also debug like Lotobarb and iSystem we are engaged now, and tools like LDRN and Parasoft. Okay, so Andes has a long-term commitment to customer success for the automotive industry. We have market proven for 18 years. 18 years. Yeah, there are more than 1,000 licenses and more than 13 billion shipments already. And the earliest core we keep technical supported was already 18 years. Our customer keep mass production this core and keep ship this core, and we keep continually supporting our customer for over 18 years. And this is probably the only profitable RISC-V CPU vendor now. So there's no kind of finance risk, and we engage with rich and active ecosystem, and there are many collaborations with Andes in the automotive industry. And Andes also providing competitive product portfolio. We delivered the first RISC-V CPU IP with ISO 26262 for compliance, the N25SE, and we will have our full products covered from entry MCU level to even out of the processor with certifying with ISO 26262. And we building hardware safety mechanism to accelerate customer time to market without the PPA sacrifice. So okay, basically this is the whole webinar we talked about, and thanks for your time for joining this app and this webinar. Have a good day. See you.